Hey guys, welcome back to the Linux Essentials series for hackers. In this video, we're going to be talking about file and directory permissions and ownership. Alright, so again, there's quite a bit to cover and hopefully I'll explain the various ways of doing it and hopefully I can explain it as best as I can. Alright, so let me just open up a terminal here and we can get started immediately, right? So let's just expand this and there we are. Alright, so the first thing I'm going to do is I'm just going to go onto my desktop or change my directory onto my desktop and I'm just going to clear this. Now, one thing I want to talk about before I actually get started, if I list all the files in here, you can see that directories will typically be highlighted in blue, and to keep this on a standardized basis, you want the color scheme for your terminal to be the Linux console, or you can use Xterm if you want, and again that'll just keep it really standardized. But for the purpose of this video, I'm just going to stick to the Linux console, again just so directories and your directories are highlighted blue, and again executable files are highlighted green. Alright, so that'll keep things more simple and very easy to understand. Alright, so let's get started. So again, if I list all the files in this directory, you can see that typically when I list it in the form of a list or a table, we have various bits of information. Right, so again, I can also, type this in and print it out in human readable format. But again, that doesn't explain a lot of the information that already is here. All right, so we have the first column, which is your file permissions, file and directory permissions. You then have the user and the group. All right, so this is to do with ownership. These two are to do with ownership. You then have the file size and the date modified, and of course you have the file or the directory name as is and as was created. All right, so what I'm going to do is, the first thing I want to do is I'm just going to create a simple file. I'm just going to call it test.sh because I know many of you don't like me sticking with one type of file. And what I'm going to do is I'm just going to cat the contents of the password file into the test.sh file, right? And I can just hit enter and we can clear this out. And let me also create a directory here and we'll just call it test, and let's clear this out. All right, so now if I list all the files here, you can see that we have the new files that we just created, test.sh and the test directory. So if we take a look at the permissions for the sh file, which is a shell file and is potentially executable, however, in this current state, it isn't. And you might be asking, well, why isn't it executable? And that's where file and directory permissions come into play. Now, permissions in Linux are very, very simple to understand. Now, many people usually, complicate it quite a bit, and there isn't a need for this. Again, there are two ways of handling it, which is where most of the confusion starts. That is the symbolic mode format and the octal mode, or the binary mode, as it's so referred to as. All right, and these basically deal with various techniques as to which you can ascertain or set the various permissions for files and directories. But the first thing you need to understand, first of all, if you're a beginner, is there are three types of permissions that you can apply to a file or directory in Linux. Those are read, which is represented by R, as you can see right over here. The second one is the W, or the write permissions. And the last one is the X permission, which stands for executable. So these basically mean read. This means that you're allowed to read the file. The write permission means you're allowed to write changes to the file. And the X permission means you're allowed to execute the file. Now you might be saying, well, we have various sequences of these permissions appearing here. How is it sorted out? And that's a very good question. So let's take a simple example of the test.sh file right over here. All right, so first of all, as you'll see right over here, each of these is sorted into six columns. They're really not separated, but that's how you have to understand them. So you have your first one here, you have your second one here, and you have your third one here. Now this initial prefix here is there to tell you the type of file you're dealing with. In this case, we're dealing with a file, so it leaves that blank. in the case of a directory, it will be annotated by a D, and that tells you that you're dealing with a directory. All right, so let's talk about the other columns here. So the first one here is for the owner of the file. All right, so these are the owner permissions. Now, when we're talking about ownership for this particular file, we can see that the owner of the file and the group that it belongs to is Alexis. All right, now if it belonged to another user, that means that these permissions were specific to that particular user or the owner of the file. The second column here is these are the permissions for the group. All right, so again, these are group permissions, and the last one are for all other users on the system. So let's say I created a file and I'm currently in the Alexis, the home Alexis desktop directory here. Let's say I was logged in as another user and I navigated into this directory and I tried to execute this file over here. Well, given that I was using another user, the permissions for this file explicitly state that I can read the file. However, I cannot execute it or I cannot write any particular changes to it. So hopefully that makes sense. Now, let's talk about changing these permissions or setting these permissions for these files. Now, this is where the chmod command comes into place. All right, so the chmod commands allows you to change the mode for files and directories and allows you to change permissions for the file and directories. So again, I can use the whatis command with chmod, and you can see it allows you to change the file mode bits and change the permissions of a file or directory, right? Quite simple. Now let's talk about this for a second. It's very easy to use. We say chmod and then we specify the options that we want, and finally after the options we specify the file to which we want to apply these permissions to. All right, so very simple syntax. However, as I mentioned, there are two ways of doing this. Many people are comfortable with their own way, and I recommend that you find your own way of going about this, but I will make a recommendation to make things a whole lot easier and maybe one way that you can understand it, a whole lot better. All right, so that the first way is by using the symbolic mode format. All right, and the second way is by using the octal or the binary mode. All right, so let's start off with the symbolic mode format. All right, so let's say I wanted to change the permissions for the file test.sh right over here. All right, so you can see that we currently cannot execute it. So what I'm going to do is let me just remove, or I can just what I can do is just cat etc, or we can just say dev null, and don't worry what I'm doing here. I just want to .sh, and we can actually just say echo. We can say echo hello world, and we can just use this and we can pipe that into the file test.sh. and now if we try and execute this file, you can see that we hit enter, we can see that we do not have the particular or the necessary permissions to execute this. So that will be our goal here. Our goal is to set or to provide the user Alexis with executable permissions. All right, so let me just list this one more time and we can take a look at the permissions. So for the owner Alexis, he can only read and write changes to the file, which we pretty much did already. For the group, they can only read the file. And for all other users, they can only read it. All right, so let's talk about the symbolic mode format. So the symbolic mode format is very simple to understand. Of course, I've mentioned it has to do with the various permissions. So read, write, and execute, and it is done in conjunction with the chmod command. All right, so now with the chmod command, I can now specify the specification in regards to the user, the group, the other, or for all users. All right, so what this means is if I wanted to specify permissions or set permissions for the current user, I would do that by typing in chmod u, and then I can add permissions. I can say u, I can add permissions by using the plus sign, or I can say u is equal to, and then I would set the permission. So I can say user, the current user is going to be read, write, and execute. We're going to provide this user with the read, write, and execute permissions, and then we specify the file that we want to apply these permissions to. So I can say test.sh. All right, and I can hit enter. Now, if I list all the files here again, you can now see that the user Alexis or the owner Alexis has read, write, and executable permissions, which means we can now execute this file. And we just entered a simple piece of code here. So again, we can say test.sh, and again we can actually just modify this. Sorry, we can say just going to test.sh, and we can just say echo, so that whenever we print it out, we can actually get those this little string of text here again. So let me just write and exit there, and you can see that that was successful. So again, if we execute the file here, you can see it prints out the string hello world. Excellent. So now we have set the permissions for the user using the symbolic mode format. All right, so we can also remove permissions, and again I've shown you how to explicitly set the permissions. So again, let's go over that one more time. So chmod. And now let's say we wanted to apply these same permissions for all the users on the system, all right, and for the group. All right, so to do this, we use the group and the O sign, or we can also use the A sign, all right, and that will mean group and all other users on the system. So group and all other users on the system. So again, the standard definition is U for use, the current user or the owner of the file, G is for the group, and again O is for other, and A is for all. All right, so that will set for all. So we can say group, and we can then say group and other will have read, write, and executable permissions, and then we specify the file here, and we hit enter, and then that will set the permissions explicitly. So again, if we list all the files now, you can see that the current user, the group, and all other users have read, write, and executable permissions, which means I can now execute this file if I was logged in as another user that belongs to any other group on the system, which is not recommended. So let's talk about how to remove these permissions. All right, so I can say chmod, and let's say I wanted to remove the write and executable permissions for the groups and other users on the system. So again, we say go, and now we say minus wx, so the write and executable permissions, and we say test.sh, and we hit enter. And now if we list all the files here, you can see that now we have removed all these permissions. So the current user is only allowed to read, write, and execute the file. However, the group and the other users on the system are only able to read it. So that is essentially how to use the symbolic mode format. So you can see it's a very simple system to use. Let me just go over it one more time. We use the chmod command. We then specify the user, the group, other, or all. All right, so again, UGOA, that is the standard definition there. And then of course we use the plus or the equal sign to add permissions or to explicitly set them. So for example, if I wanted to give the group executable permissions, I would say chmod group plus X. All right, so we're setting it for the group and we're giving it executable permissions. We then specify the file and we hit enter. And now if we list all the files here, you can see that it gives the group executable permissions, so it can read the file and execute it. However, it cannot write changes to the file. So I can also get rid of it. So again, chmod minus, we can say group minus X, so remove the executable permissions, and then we specify the file. We hit enter, and again, if we list the files here, you can see we're back to the old permission. So again, a very simple way of setting permissions. All right, now let's talk about the binary or the octal mode of setting permissions. All right, so now let's talk about the octal or the binary mode of setting permissions, right? Which is again very simple and is my preferred way of actually going about doing it. Now again, as I said, it's entirely up to you. All right, so again, we are still using the chmod operator here. And again, this is the standard. So again, we can say chmod, and then now when dealing with the binary or the octal mode of setting permissions, the read, write, and executable permissions are now denoted in a binary format. And you might be saying, well, if that's the case, doesn't that make it a little bit complex? Well, I'll explain why it will not make it complex. All right, so let me explain something. So typically, as I said, the read, write, and executable permissions are now represented by a binary value. All right, so the read value is the read permission is represented by a value of 4. All right, the write permission is denoted or represented by a value of 2. Sorry. And the executable permission is represented by a value of 1. All right, and again, we're still following the previous format of actually understanding permissions here. So again, we have the owner now, the owner of the file or the directory. You then have the group and others, other users on the system. All right, so let's work with the test.sh file, and I'll talk about setting directory permissions, which is again very, very simple as well. All right, so let's say we wanted to get rid of the write and execute permissions for the owner of the file, which is right over here. You can see it has read, write, and execute permissions. So to do this with the binary mode or the octal mode, again, we need to specify chmod. And now the permissions, if you already know about this, are now represented by the by binary values. All right. So as I said, for the owner, we want to actually specify the following. So again, we can say chmod, and for the owner, we need to specify we want to get rid of the write and executable permissions. So we only have the write permission, which again, as we said, is going to have a value of 4. All right, so we start off with the value of 4. So we're going to say chmod 4. And then for the other files, also for the group and for the other users on the system, we want to use the same permission. So we're going to say chmod 444, and then we specify the file name, test.sh, and we hit enter. And now if we list the files in here, you can see that now the file only has read permissions for the owner, the group, and other users on the system. All right, so that's how to set it. Now, if I wanted to give the owner of the file read, write, and execute permissions, we would need to add these binary values together. All right, so read is going to be equal to 4. All right, write is going to be equal to 2, and execute is going to be equal to 1. All right, so 2 plus 4 is going to be 6. 6 plus 1 is going to be 7. So we say chmod 7. That is for the user permissions or the owner permissions. So read, write, and execute. Let's say for the group and the other users on the system, we want to give them only read permissions, which again is denoted by 4. So that's 4 read permissions for the group, and for other users on the system, the same thing. And then we type in the name of the file. All right, and I'm going to hit enter. And we can now display this, and immediately you can see we now have read, write, and executable permissions for the owner. For the group, we only have read permissions, and for other users on the system, we only have read permissions. All right, so that's very easy to understand. Now, if it is complex, I will leave a resource in the description section that has a table of all of these permissions, but the math is very simple, right? So again, we're simply adding 4 plus 2 plus 1, and that is for all permissions. So this is write, so again, this is this is read, write, and this is execute. So 4 plus 2 plus 1 is going to be 7. If I only want read permissions, it's going to be 4. If I only want read and write permissions, it's going to be 6. So again, that would be 7, 6, 6. Or if I only wanted read and execute permissions, that would be, so for example, if we wanted for the user or the owner, read, write, and execute permissions, that would be 7. And then for the group and for all other users, we only wanted read and execute permissions, that would be 7, 5, 5. All right, so it's very easy to set permissions this way. And again, you're always setting explicitly for the user, for the owner, the user, the group, and then all other users on the system. So that's something you need to take into consideration. All right, so now let's move on to actually changing directory permissions. All right, so if I list all the files here, again you can use the symbolic mode or the octal mode, whatever is comfortable with you. We have the test directory that we created. So again, if we wanted to provide it with all permissions, you can see that it has read-write permissions for the current user, and for the group and the other users it only has read permission. So again we can say chmod user. If we use the symbolic mode, we can say user group and other. That's going to be equal to read, write and execute, and then we say test, the name of the directory, and we hit enter. And now if we list all the files in here, you can see that the permissions have been set. And then again, if we wanted to go back, I can say chmod, and let's say we only wanted the file to be we only wanted the user to be able to read and write to this particular directory. Then we would say this is going to be equal to 4 plus 2 is going to be 6, 4, 4, and then we say test and we hit enter. We hit again, we can just confirm the permissions have been changed, and there you are. So that's how to set permissions on a directory. However, if there are other directories and files within this directory, then we need to set these permissions. We can set them recursively, and to do this we can then type in chmod, and if we use the R command, the capital R command, that means recursive permissions. So again, we can then say, before we do that, let's actually move this file, the test file, the test.sh file, into the test directory. And you can see it tells us that we do not have adequate permissions, and that's because, again, if we list all the permissions here for the directory, if we say, for example, for this particular file, let's say we want to say chmod 755 test.sh, and now we say move test.sh into the test directory, and we hit enter. That is telling us that we cannot move it. That's primarily because of the permissions for the directory. So we can say chmod 755 test, and we hit enter, and then we can say move, we can then say test.sh into the test folder here, and we hit enter, and now we can move it. All right, so that proves again the importance of permissions and understanding them. So now if we check the directory test, the files within the directory test, we have the test.sh file. So now if we wanted to actually provide this directory and all the files within it, files and directories within it recursively with all permissions, I could say chmod 777, and that gives it read, write and executable permissions for the owner, the group and all other users on the system. So again, I would say chmod recursively 777, and I'm using the octal mode, as you would have guessed, and then we specify the directory, and I hit enter. And now if we list all the directory itself, you can see it has all permissions. If we list all the files within the test directory, if we list the permissions here, you can see that the test.sh file now has also those permissions, and they have been applied recursively. So if I had any other files or directories within this directory, they would have been applied as well. All right, so now that we have actually taken a look at file ownership, file permissions, let's take a look at file ownership.